Alright, I got this book for Christmas. We're going to do a PowerPoint slide presentation on this. Alright, hi. Tracing schematic wire diagrams on diesel electric locomotives, Electric Motive Division, General Motors Corporation, LaGrange, Illinois, USA. Tracing schematic wire diagrams on diesel electric locomotives, Locomotive Division, General Motors Corporation, LaGrange, Illinois, printed in the U.S. 1952. Introduction. Locomotives of the day are called diesel locomotives, but our true name is diesel electric locomotive. The diesel engine drives the generator. From there on, most everything is electrical. The electrical systems are more difficult to understand. It was generally agreed with electrical troubles are causes of most delays, which is in the mind with the ability of tracing schematic wire diagrams will be tremendously an asset to both the operating and maintenance man. It will enable him to better understand how his locomotive operates and gives him the means to rapidly troubleshoot correct most of the problems that might arise in the operation. Is very likely that the first time you ever looked in a wire diagram you threw it up your hands in disgust after seeing the maze of the wires and symbols. Actually, a schematic diagram is relatively easy to read, provided that you analyze the circuits individually and somewhat the reading of the road map. Which I may sure all of this uses, may sure all of us have done one at a time and another. Speaking of the road maps, reminded of the analogy I might give and then show the comparison value being able to read the maps and diagrams. Suppose you were taking a trip from to California in your car with don't have a road map. You would probably would be to head westward towards the setting sun, not knowing proper roads to follow. Would you make the trip extremely difficult and lengthy and discouraging, particularly if you had to be in California in a hurry? You would probably be on bad roads and detours with the general go to the ultimate reach with your goal, go in circles around in circles. The chance, however, that if you are present well, you will have ultimately reached your goal. Now, taking the same trip with the road map would be another story. You could plot your course, make the trip easily with a minimum delay. The same with the thing that holds true with troubleshooting of locomotives is perhaps it's reported that the locomotive is not loading up. Of course, that that the main reason for this is the shunt in the battery field contactors not closing. Wire diagrams, the method would be sort of a hit or a miss. Checking everything in the site with the contacts, relays, interlocks, switches, and fuses, since most of them have not bearing on the problem at hand, on a lot of time would be wasted. I'll grant, however, that you might ultimately find your trouble. It's just like driving to California without a road map. How much better would it be to solve the locomotive problem with the help of a wiring diagram using this would be spot yard goal, which in our example of the SH and BF contactor. The tracing of the circuits would be known to exactly the contactor, interlocker, switch, and to look at. In this way, our trouble can be found with the minimum delay. It is assumed that fairly well acquainted with you are fairly well acquainted with the electrical symbols, legend used in these diagrams. One thing might bear mention, however, is interlocking in their identification. And interlocking is not an individual piece of equipment existing of itself, rather the part of the sum of the relay and the contactor actuated with the relay or the contactor. For example, the shunt field contactor has one interlocking on it. It is referred to as the AB interlocker shunt field contactor, or more briefly, the ABSH. AB of SH, the contactor made several sets for the interlocking. In this case, you would be given additional letters alphabetical such as CD-EF-GH and so on. You will note that some of the interlocks are closed, that are open when contactor controls them is open. Thus, they are referred to as normally closed, normally operating interlocks. When controlling contactor closed with the interlock changing position, those that were previously closed now open. Those that were now closed, the performance of the function, making and breaking electrical circuits to be obtain desired results. In tracing circuits, it must also be remembered that electricity will not flow until the complete path or circuit is established for it. Electricity will flow from the source of such a battery generated to some of the devices to be operated, then return to its source. Upon thus completing the circuit, you might say that the electricity will not start flow unless it has a round-trip ticket. On the diagrams that we shall trace, it will be noted that the bottom of the wire is common wire leading, and to the negative side of the battery, many devices are connected with the wire, and hence it will be necessary to trace all the circuits back to the source. The circuits that we shall trace will be those of the electrical motive model 57 F7 locomotive. It should be remembered that similar circuits are used on the other General Motor locomotives. Thus, it will be understood to trace the diagrams of one of the locomotive. All others will be very similar. The tracing will be made with the following order. 1. The fuel pump circuit. 2. The engine starting circuit. 3. The auxiliary generator battery charging circuit. 4. The locomotive control circuit. 5. The excitation circuit. 6. The engine speed control circuit and transition circuit. Alright, circuit 1, the fuel pump circuit. Starting with the positive side of the battery, we go through the main battery knife switch, ammeter shunt, and the control switch to the 30A control fuse. Going from the fuse through the control push button into the cab, we come out of the PC wires. Runs through the locomotive coming up from the PC wire we will go to the throttle control stand where it contacts is made with the two fingers touching the metal bar where the throttle is in the idle position. From here, they will go through the PCS contacts into the PCR coil. Note that the PCR interlocking with the CD above will now close, establishing the holding the circuit with the PCR. It can stay and energized with any of the throttles open. From the PCR coil, but the circuit is completed with the back of the negative side of the battery through the 80A control fuse and control knife switch of the main battery switch, continuing through the positive control switch wiring coming from the control switch. We will go through the 15A fuel pump circuit fuse fuel pump switch button located in the cab of the AB. Interlocking PCR of the PCR will be closed in action of the PCR and coil previously entered. From those, it will enter the FP wire part. This includes the FPC coil when turns for the close for the interlock of the AB and CD of the FPC and the fuel pump motor circuit. Now coming from our positive control wire, we go through the 10A fuel pump motor fuse and the AB and the CD of the FPC. Thus, the fuel pump toggle switch directly to the fuel pump motor. Alright, the following is a list of abbreviations used to identify electrical equipment on the schematic diagram. The diagram is designated to conform with the identification bands of the wire and locomotive. We're going to go over this 5 or 6 times in the just listen up. The wiring diagram in Chapter 6 shows the contactor switch and relays on the non-dynamic A unit with the engine stopped and all manual switches open. It must be remembered that when the operating coil of the contactor becomes energized, the contacts and interlocks associated with the contactor then will be in position opposite and they show the diagram. The AC1 and AC2 and 3 and 4 are cooling fan motor contactors. The AM stands for battery charging ammeter. AV, BV, CD, CV, and DV are governor control solenoids. B1, 2, and 3 are dynamic brake contactors. BA is a boil alarm alert. BC is a battery charging contactor. BF is a battery field contactor. BTP is a backward transition relay. BW is a dynamic brake warning light. BWR is a dynamic brake warning relay. CC is a compressed control magnet valve. CCS is a compressor control switch. COMM is a communication field. COMP is a compensation field. CR is a compressor control relay. CS is a cam switch power bracket transfer switch. DIFF is a differential field. ER is an ER relay. ETS is an engine high temperature switch. FL is a field loop contactor. FOR is a reverse magnetic field forward. FPC is a fuel pump contactor. FTM is a forward transition relay or for motor shunting. FTP is a forward transition relay parallel. G is a ground light. GA is a gauge light on the switch. GR is a ground relay. IM is the load indicating meter. IS is an isolation switch. LOS is the lube oil switch alarm. M, it stands for motor shield shunting magnetic valve. Motor shunting magnetic valve. M1 and 2 and 3 are motor field shunting contactors. MOT is a cam switch of magnetic valve for the power position. N is a number light. NV is an alternating failure of the signal light. NVR is a no AC voltage relay. ORS is an overriding solenoid in the governor. QS, I guess that's an OS. Low oil signal light. P1, 2, and 3 are parallel contactors. PCR is a pneumatic control relay. PCS is a pneumatic control switch. PR is a parallel relay. RCR is a reverse current relay. REV is a reverse magnet valve relay. A reverse magnet valve in reverse. RVR is a reverser. S14 and S23 is serial parallel contactors. SH is a shunt field contactor. SMV is a shutter magnetic valve. SR is a signal relay. ST plus and ST minus are starting contactors. Start stands for starting field. SWS is summer winter switch. TCR is a temperature control relay. TOW stands for cam switch magnetic valve for dynamic braking. TS is an engine high temperature light. WSA is a wheel slip auxiliary relay. WSR1 and SR2 is a wheel slip relay, and WS is a wheel slip light. All right, starting from the top left-hand column down, we work our way into what looks like a circle with two blocks on the end of it, which stands for a generator or motor armature, and then you have a zigzag line, which stands for a coil of the generator, field motor, field relay, or a contactor. So you either have a field motor, field relay, or contactor on the coil generator. There's a when you have a zigzag in parentheses, double parentheses, it stands for reverse contactor and series field. Just like in a door on a drafting situation, you see a heart line with a single switch, or a door opening that stands for the contactor blowout coil. All right, now you're given a little key like a puzzle piece. That stands for drum type switch. And then you have interlock. Your interlocks are like straight lines with two points on them with a door that is closed, or should we say like a block on the side of the in between the lines of the spots. All right, a storage battery has a small and large dashes in between a minus and a plus sign. A fuse is a squiggly line where the SA stands for a fuse and fuse 5 amperes. If it has an F over it, like it will say how many amperes it is. An ammeter with a shunt shows an A in a circle above and what looks to be like an interlocking without a shade. A significant celsium rectifier is a triangle with a letter T, or with a parallel line at the top of the arrowhead. A light receptacle is a circle with two lines through it. A backup light receptacle is a circle with two dots in it. And a battery charging receptacle is a circle with a circle in it. And a light is just a circle. Your transformer air core is a two squiggly lines that happen to be parallel to each other but not touching. The transformer iron core vertical current lines with lines going through them. Your single pole knife switch as a cross for a door, like a gated wire. The double pole knife switch has a two door openings lined together. A single pole snap switch has a small dot on the gate to the relay. Also, the double pole snap switch has a pull out a line through it, like it's done like the double pole knife switch, but with a line through it. Your push button, it shows a blocked off with a button on the what looks to be like an interlock, and your push button on the interlock without a spring is a push-pull switch. All right, your fixed resistor is a tooth line or a block line, And your variable resistor is a tooth line or a block line going in a circle loop. All right, a thermal relay is a two block is I don't know. Just look at it. Two negative side battery is a circle with a negative on it. That means two negative side battery. The wire ground to the locomotive is a line with small dashes in a triangular bottom shape. And circuit continued on or another path is formed with an arrowhead going that shows the circuit and continued on that path on another plate. Wires connected shows as a dot with a full line going through them. Capacitors are either the Y coupling or the two Y couplings. Your circuit breaker knife switch has a toothed push button, tooth push pull, or a snap pull switch with a tooth, and a circuit breaker. Rheostator is a current field, coil generator field, or relay contact with a arrow pointing on the inside of it and made it in a circle. All right. All right, here on the top one, I'm going to move my cursor over here. You see a 64-volt battery with a BTN, which is the, doesn't say, battery terminal positive and negative through a double pole switch to an ammeter, which goes through the on one side of the control switch, which goes through another double pole control switch at 80 amperes. And this circuit runs on 80 amperes on the bottom, and which was the negative, and the positive from the second control switch through the ammeter goes to a control through a 30 amp fuse to a control stand. Also back to the PC, which is probably a pneumatic parallel contactors or pneumatic control. This is for your fuel pump circuit. Your fuel pump circuit goes back, rides the after the still on the negative positive side of the double switch amper switch. On the other end goes into two lines: a PC and patrols pump circuit and a fuel pump circuit. Which the fuel pump goes through a 15A and then another push button fuel for the fuel pump and interlocking fuel pump with a interlocking fuel pump push button switch. There you have your B&A. And then the fuel pump wire comes back through the field coil current back to the which goes down the 88 side of the battery terminal, which also the negative terminal also before going on the 88 terminal has a 10-ace fuse breaker to two interlocking fuel pump controls, A, B, and D and C. These are the points, and snap button, a single pole snap switch going through a motor with the current around the fuel pump for the motor for the fuel pump. Also on the back side of the fuel on the patrol pump circuit, the fuel pump circuit, there's a PCR, which is pneumatic control relay, and pneumatic control switch. The pneumatic control relay and switch is over here with two interlockings from the two field currents, the fuel pump circuit and the pneumatic control relay to the pneumatic control switch, which goes into a 2-point C and D of the pneumatic control relay. And these relays go from the PCS switches to the throttle control, which has 8 different notches, and you have your drum tight switches. And these are stop, idle, and these control the fuel pump switch and at the throttle control. Circuit 2, engine starting circuit. The next circuit is a sequence will be start of the engine through the starting circuit. The PC wire with the control the control circuit previously established, we can come down from the AB finger of the isolation switch, which will be closed on the isolation switch in the start position. From there, we go through the start button, push to the start contactor, coils of the STP, not positive to negative. These coils will still ST positive and ST negative. These coils close with the contactor ST plus and ST negative. High voltage system battery control circuit that flows to the positive connection just below the main battery switch from 400 amperes starting fuse to the start positive contactor main generator armature differential componentation communicating starting fields main generator and the ST contactor back to the negative side of the battery. The main generator now acting back on the negative side of the battery. The main generator now acting as a motor cranks to start the diesel engine, and the starting button can now be released, which breaks the circuit of the ST plus and ST negative coils, which allow the start ST plus and STI negative contactors to open and disconnect the battery from the main generator. Once again, AC 1, 2, and 3 stands for cooling fan motor contactors. AM for the motor battery charging ammeter. AV, BV, and CV and DV stands for governor control solenoids. B1, 2, and 3 stands for dynamic braking contactors. BA for the boiler arm light. BC for the battery charging contactor. BF for the battery field contactor. BTP with the backward transition relay. BW with the backward warning light. BWR dynamic backward warning relay. CC compressor control magnet valve. The CCS the compressor control switch. The COMM communication field, and COMP for the compensation field. For the CR for the compressor relay. The CS for the cam switch power braking transfer switch. DIFF differential field. ER relay. ETS engine high temperature switch. FL field loop contactor. FOR for reverse magnet valve with the forward. FPC the fuel pump contactor. FTM the forward transition relay. FTP with the forward transition relay parallel. G for the ground light. GA for the gauge light switch. GR for the ground relay. IM for the loading indicating meter. IS for the isolation switch. LOS lube oil switch. Alarm. M stores for motor shunting magnet valve. The M1, 2, and 3 and 4 motor field shunting contactors. MOT for the cam switch magnet valve for the power pump position. M for the number of the light. NV for the alternating failure signal light. With the NVR for the no AC voltage relay. ORS stands for overriding solenoid. M with the governor. With the OS for the low oil signal light. With the P1, 2, and 3 and 4 parallel contactors. PCR with the patrol and pneumatic control relay. PSCS with pneumatic control switch. PR parallel relay. RCR reverse current relay. REV reverse magnet relay. Reverse RVR reverse S14 and S23 serials parallel contactors. SA shunt field contactors. SMV shunt magnet valve with the SR signal relay. ST plus and ST9 is starting contactors. Starting field. SW summer winter switch. TCR temperature control relay cam switch magnet valve with the forward dynamic braking engine. TS engine high temperature light and WSA swiftly. Wheel slip auxiliary relay, wheel slip WSR1 and WSR2 wheel slip relays on WS wheel slip light. Once again, you have your generator motor field armature, the coil generator field with the field relay contactor, the reverse contactor series field, a contactor will blow out of the coil, the drum switch type, the interlocking normally closed. The storage battery, the fuses, the ammeter, the solenoid rectifier, the light receptacle, the backup light receptacle, the battery charging receptacle light, and the transformer error core, the transformer IR core, the single double pole switch night switch, the double pole night switch, the snap pole snap switch, the double pole snap switch, the push button switch, and the push pull button switch. Your tooth and box fixed resistors, the tooth and box looped variable resistors. Thermal relay is what it is, and the negative side of the battery shows a negative on a circle at the kind of like wire ground with the pyramid of dashed lines. A arrowhead for the continuing circuit on another plate. Wire connected at the points, just like in geometry. The coupling of seam, a capacitor, and of a Y and a 2Y seam. Also, a tooth snap relay, circuit breaker, resistor, rheostator. Your engine starting circuit. Starting from the battery, you have a battery terminal positive, which goes through a double main switch positive. That positive switch goes through an ammeter with the control circuit, and then from the control double throw switch, it goes to a fuse, a 30 amp fuse with a a push button control with a positive the PC goes to now to a uh, what's IS stand for? Isolation switch with a push button switch, starting with a and then to the push button switch, and then into your starting track. Your starting ST stands for your starting contactors negative and positive through a field current, which goes back through the loop from your original battery transfer terminal. In the line of an 80 amps back into following the battery terminal around through a starting to a negative terminal. This goes that the battery terminal positive going back to the pole switches, and then before it goes back to the first pole switches on the positive negative and positive negative battery terminal positive switch, it would go from a 400 amp fuse to a starting contactors positive and negative at these two relays. Which on this relay there's a contactor with a blowout switch. You got a contactor with a blowout coil on your contactor positive, and the starting transactor. Your starting transactor parallel the STP within to the motor gasoline to a differential current with a compressor current with a communicating current. Compensation commutating current with the field relay and another blowout coil that you're starting a negative, which goes back to goes back and flows back through the original main battery switch, which is a double pole switch on the negative side of the 64 volt storage battery. That was your engine starting circuit. Circuit 3, auxiliary generator battery charging circuit. Now that the engine is running, the auxiliary generator begins with the charge of the battery with the flow, supply of low voltage current with the locomotive that's followed for the positive side of the auxiliary generator armature flows and through a 30 amp auxiliary field fuse, then through the two passes for the voltage regulator, and first go through the regulator variable resistor auxiliary generator field, but the other goes through the resistors and the regulator field widening to regulate the voltage output. These two passes are combining leading back through the commutating field for the negative side of the auxiliary generator armature. Now just above the 30 amp fuse will flow up through the 150 amp auxiliary generator output as used for the connection with the leads of the reverse current relay. We feed through spring loaded leads for the reverse current relay. We would feed through the spring loaded finger with the variable resistor voltage back into the negative side of the auxiliary generator where the proper voltage is reached with the voltage coil with the spring load finger with the opposite contact with completes with the circuit with the battery changing coil with the BC coil closed with the BC contactor to show the auxiliary generator can go through the current coil of the RCR to the BC contactor with the auxiliary generator with the nice switch the 500ths of an ohm charging resistor, the amp shunt and main battery switch to the positive side of the battery, the flow from the negative side of the battery through the main battery switch, the auxiliary generator switch to the negative side of the auxiliary generator. When the engine is stopped, the auxiliary generator voltage falls below the specified amount. The flow will tend to reverse the battery through the RCR, which action allows the spring to pull back the finger braking circuit through the BC coil. But the opening of the BC contactor breaking with the circuit through the BC coil with the opening for the BC contact with the disconnect of the battery with the auxiliary generator, preventing with the battery current for the motorizing of the damaged auxiliary generator. Another important function of the auxiliary generator is to excite the alternator done with the current flow of the auxiliary generator through the 150 ampere output fuse for the connection immediately above the fuse, going left of the connection through the 385 ampere alternating field fuse. The 3.3 ohm resistor slip rings to excite the rotor field, then return for the negative side of the auxiliary generator. These three phases of the alternating current induced with the flow feeds for the traction motor blowers and the engine cooling fans. The NVR stands for no voltage relay, is a safety device to ring all bells and cutting off the locomotive power such should an AC output fail. All right, the legend of the electronic equipment. Once again, in the AC 1 and 2 and 3 and 4, a cooling fan with motor contactor to the AM, it's battery charging ammeter. AV and BV and CV and DV stand for governor control solenoids. B1 and B2, B3 stands for dynamic braking contactors. BA stands for a boiler alarm light. The BC for the battery charging contactor. The BF for the battery field contactor. The BTP backward transition relay. BW for the dynamic brake warning light. BWR for the dynamic brake warning relay. CC for the compressor control magnet valve, the CCS for the compressor control switch, the COM for the communication field, COMP for the compensation field, CR for the compressor control relay, the CS for the cam switch for the power braking transfer switch, DIF the differential field with the ER for the engineer ER relay with the ETS stands for engine high temperature switch. The FL stands for field loop contactor. The FOR stands for reverse magnetic valve for the forward. FPC stands for fuel pump contactor. The FTM for the forward transition relay for motor shunting. FTP stands for forward transition relay parallel. G stands for ground lighting. GA stands for gauge light or switch. GR stands for ground relay. IM stands for load indicating meter. IS stands for isolation switch. Lube oil switch stands and alarm is an LOS. M stands for motor shutting magnet valve. The M1 and M2 stands for motor field shunting contactors as M1, M2, M3, M4. MOT stands for cam switch magnetic valve for the power position. N from the number of the light. The NV for the alternating failure signal of the light. The NVR for the non-L the AC voltage relay. AORS stands for the overriding solenoid. And the governor of the OS stands for low oil signal light. P1, 2, and 3. P1, P2, P3, P4 stands for parallel contactor. PCR for the pneumatic control relay. PCS for the pneumatic control switch. The PR for the parallel relay. RCR for the reverse current relay. The REV for the reverse magnetic valve. The reverser. RVR stands for reverser. S14 and S23 series parallel contactors. SH shield field contactors. SMV and shield magnet valve. The SR signal relay. ST plus and ST on starting contactor. Start stands for a starting field. SWS stands for a summer winter switch. TCR temperature control relay. TOW cam switch magnetic valve for dynamic braking. TS engineering high temperature switch light. WSA wheel slip auxiliary relay. WSR1 and SR2 wheel slip relays, and WS wheel slip light. Once again, you have your armature, your coil generator field motor, and contactor. The reverse contactors in the series field. A heart line with the switch is the contactor with the blowout, and bit is a drum switch type switch. Interlocking is a board behind a little gate, interlocking normally and interlocking close. You have a battery with small and large dashes vertically and positive and negative sign, and the fuse is a swivel line with the amperes above it, an ammeter with an A over it. The rectifier is an empty non-filled arrowhead with a dash at the pinnacle. Circle is a circle with on a line with the two lines through it. The two dots through a line with the backup light receptacle. Circle and a circle on a line is a battery charging receptacle. Battery circle on the line stand for a light. Your current fields on the vertical standing stands for parallel but not contacting or transfer air core. Your current with the parallel lines of iron cores in between them stands for a transformer iron core. Your single pole switch is a cross of as a switch as a gate, and two double gated wire is a double pole switch, and I switch. A snap pole switch has an arrowhead on the on the gate. Also, your double pole snap switch has a gate with a line through it with a push button. Your interlocking shows our push button switches and pull button switches. The tooth in the box line stands for fixed resistor or variable resistor. It shows a loop in the fixed resistor or the tooth or bowl blocked line. Then you have a little thermal relay for whatever that means, and a negative for the U side of the battery shows as a ended circle with a dash through it, and a wire grounded for the locomotive shows a triangle with a dash line through it. A arrowhead with a full in arrowhead connections of the filled with a dotted across the line. Couplers of a Y seam or a double Y seam is a capacitor, and your circuit breaker is a tooth lined with a snap with a single pole snap switch. A rheostator is a current and been in a circle with a arrowhead. The circuit continue for the another touching the plate of the rheostator. All right. Let's see. We did engine starting. We're on battery charging. You have your 64 volt battery terminal negative and battery terminal positive. Your battery terminal positive will find that line first. Your battery goes through a double pole switch, and then through the ammeter, and then through a fixed resistor at 5 ohms, and then the battery charging contactor is on a single pole switch, going from positive to negative, and then the current goes through a parallel circuit, which leads into which looks to be the RCR, which is the reverse current relay. The reverse current relay has a two fixed variable resistors on a single switch. On a switch relay, and then from the second fixed resistor, it goes into a current. These and the reverse current relay goes back to the BC, which is the battery charging terminal. And this leans into the AGN, which is the it was not stated the AGN. All right. As you can see, that also the battery charging unit line from the positive battery terminal positive on the outside of the circuit goes to 150 amperes, then through a 30 amperes. In between the 150 amp and the 30 amp fuse, you have an auxiliary generator and positive and negative commutator field. On this, we'll get to this single side of the before the alternator, all these connections. But from right now, we're running on the right side, and then from underneath the 30 amperes runs on a circuit which goes through a voltage relay and a variable fixed resistor, two variable fixed resistors with a motor on it, which would be probably for the voltage relay battery charging, and and a current field flowing through a regulated field are two variable resistors. Then the field coil, the FLD field coil, the field main, your compensator, the battery charging, and the AGN are all on the back side of the battery terminal negative positive, which goes through a fuse of 35 amperes and a fixed variable resistor of 3.3 ohms to a what looks to be an armature of a field coil and a alternator on a current. These over here you see the battery charging fuel cooling fans, 3 and 4 going through AC interlocks, AC4, and an NVR. AC voltage relay here on which looks to be a 3-way winding and also a current from the NVR to double phase 3-way winding. Alright, circuit 4, locomotive control circuit, and I'm going to take a break, and we'll come right back to this. Testing. Alright, circuit 4, locomotive control circuit. The next step of our sequence is to get into the traction motors connected with the generator that is done with the following manner. From the control push button, we go down to the PT2 finger that is touching the metal with the throttle drum. The throttle is open with the finger to the number 1 position. The drum moves toward the slide under the EX finger. The circuit is now completed with the drum out with the EX finger for the use with the generator field push button. Closing the button sends with the contactor with the GF wire with the wire. We tap off it and come down to the stop of the finger with the transition drum. We tap off the transition drum. All the fingers of the drum are resting with the isolation. When the transition lever is moved to the number 1 position, the power position, the metal portion of this drum slides under the finger. We stop it. It's complete with the control circuit. On another frequent finger beneath it, the flow of the ladder finger now goes into the right for the reverser section. The control stand with the stop of another from the finger with the reverse levers move with the forward position. A metal bar slides under the finger and completes the circuit with the finger above it flows from the top of the finger. Now goes down to the FO wire with across the Down to the FOR coil with the coil caused with the reverser and high voltage systems move the forward position, tapping off the FO wire adjusted above the FOR coil. Another circuit is established with the power of the contactors wave the path through the CD of the FOR, the GH and the IS, and the AB of the P1 and RQ of the PR2, the S14 coil. Between the interlockings, the AB with the P1 and the ARQ with the PR, with the wire goes into the right and down with the S23 coil. These coils closing the S14 and S23 contactors high voltage system thereby completing the depletion connection with the traction motor with the generator that can be seen with the positive side of the main generator and going down with the terminals of the GSI with the right of the point of the reverser of the contact field armature number 1 American traction motor down to the left through the S14 contact to the right of the reverser contacts field of the armature of the number 4 traction motor through the indication meter that shows the terminal GN4. From here we go on for the turn of the back of the generator armature between by the way of the generator fields, a similar circuit connecting the traction motor to the 2 and AR1 AR I3 of the main contactor being closed. All right, your Legend field, Legend electrical equipment, the AC1 and A2, and the AC1, A2, ACI2, ACI3, ACI4 is the cooling fan motor control motor contactors. The AM stands for battery charging ammeter. The AV and the BV and the CV and the DV stands for generator control. Solenoids B1, B2, B3, dynamic brake contactors, BA, the boiler alarm light, BC for the battery charging contact with the BF for the battery field contactor, BTP with the backward transition relay, BW the dynamic brake warning light, the DBWR, the dynamic brake warning relay, CC, compressor control magnet valve with the CCS, the compressor control switch to the COMM, the communicating field with the COMP with the compensation field with the CR with the compressor control switch to the CS, the cam switch, power braking transistors, transformer switch, the DIFF differential field, the ER stands for ER relay, the ETS for the engine high temperature switch, FL for the field loop contact, the FOR for the reverse magnetic field valve with the forward, FPC fuel pump contact, the FTM forward transition relay for the motor shunting, FTP for the forward transition relay parallel, the G stands for ground lighting, GA stands for gauge light switch, GR stands for ground relay, IM stands for load indicating meter, IS stands for isolation switch, LOS stands for lube oil switch alarm, M stands for motor shutting magnetic valve, M1, M2, M3, M4 stands for motor field shunting contactors. MOT stands for the contacting cam switch magnet valve from the power position. N stands for the number of the light. NV for the alternating failure of the signal of the light. NVR stands for no AC voltage relay. ORS stands for overriding cylinder in the governor. The OS is a low oil signal light. The P1, P2, P3, P4 parallel contactors. PCR for the pneumatic control relay, PCS pneumatic control switch, PR for the parallel relay, RCR reverse current relay, REV reverse magnetic valve reverser, or RVR stands for reverser, 714, 723 series parallel contactors, SH shield contactor, SMV shield shunter magnetic valve, SR single relay start contactors, S plus ST plus STI, ST negative in starting contactor start stands for starting field. SWS stands for summer winter switch, TCR for the temperature control relay, TOW cam switch magnetic valve for dynamic braking, TS engineering high temperature lift light, WSA wheel slip auxiliary relay, WSR1 and WSR2 wheel slip relays, and WS wheel slip light. As you have a blocked circle with the 2 point connection points to it, you have a general motor armature, the field coin, and the zigzag is the coil generator field motor field relay or contactor. Your zigzag in parentheses stands for reverse contactor. The series of fields a heart line with a gate switch is the contactor with blowout coil. Your drum switch type switch is a bit with lines through it. Your interlocking normal gate is a gated parallel brake. Your storage battery shows from the small dash to the large dash is vertical with a positive and negative sign at each end. Your fuse stands for a swivelly line with the amperes above it, and the ammeter stands for a A above it with it shows in the shunt. Rectifier is a non-filled triangle with a line over the light receptacle is a circle on a wire which has two lines through it, and a circle with 2 dots, and it was the backup light receptacle, and a circle through the line wiring is the battery charging receptacle. The light wiring with just a circle is the light. Two field coil generator relay parallel to each other, non-touching, is a transformer air core, and your iron core has two parallel that lines through the two different field coil monitors and generator contactors. Your knife switch is a single cross over on a gate switch. A double gate is a shows two open gates on this means double knife switch. A door with a doorknob on is a single snap switch. Two double pole snap switch is a door with a double one double with a doorknob on it. Your interlockings are more like your push button switches and pull button switches are relays, which are run on an interlocking system with a spring or non-spring for the push pull. Your tooth and blocked lines are fixed resistors. Your looped, blocked, and tooth lines are variable resistors. Your thermal relay is what it is, and negative east side of the battery shows a ended loop, end of the wire with a negative on a triangle dashed. End is a wire grounded to the locomotive. Arrowhead filled in. Arrowhead is circuit continued to another plate, and wires connected are shown with points on the lines to two lines. The Y and double Y seams are capacitors. A tooth bit with a snap single pole snap switch is a circuit breaker, and a rheostat is a field generated coil and with a circuit continued within the circuit continued on a line. All right, your locomotive control circuit. We're going to start on the battery side. Negative term. There's a locomotive control circuit. You have four different motors. You have your motor generator with a battery terminal positive with a the files are current to the GSI, which is GSI is not on the thing. Government. Governor solenoid 1 and 2 of the followed by a reverser contactor fields and one through the goes through one to a solenoid switch, a single switch contactor blowout coil to another reverser contactor to two, and then to an loading indication meter back to G94, and on the GS2 you have the second motor with a inverter contactor series field with the blowout coil to the number 3, and then the inverter field coil going back to G3 and 94, the indication load meter to G94. All right, now from the 64-volt battery, the battery negative terminal or positive terminal goes through an ammeter with a control circuit double pole switch, which goes on two different lines, a 30 amp line and a generator field coil, which goes through the controls from the 30 amp go into two different. The positive control from the 30 amp controls battery switch goes to the throttle control, which has 8 little different fingers in stop and idle. Your control from your generating fields goes into a transition relay drum type switch, and then into which looks like reverser of the reverser controlling and then you have FO and RE. Those have interlockings from FE and CD and ENF and E with a gate between H and G, and then parallel contactors 1, and these different interlockings do SH shield field contactor and a battery field BF, which is BF battery field contactor shield contactor shield shunt contactor, running back to the 88 fuse chip on the negative side, going back into the two double pole switch to the 64-volt battery storage plate, and that was the excitation circuit. Alright, circuit 6. Now that engine speed control. Now that the generator, the traction motor circuit of the generator excitation circuits have been completed, the next step of obtaining the maximum power output of the generator. This is done by speeding the engine with the means of electronic control over the engine governor. The ER relay circuit must be established before the general governor circuit can be effective. Starting the control switch before will go through the 15A with the fuel pump fuse, the fuel pump fuse push button with the PCR pneumatic control relay interlocking with the AB with the established the fuel pump wire circuit. This circuit will discuss the connection with getting in the fuel pump started through the wire that come down through the JK and IS, which will be closed with the running position, the AB for the no voltage relay. Which will be closed with the action of the alternator generator electricity virtue for the being turned on for the engine, the CD, and the GR with the ER relay coil. This will close the ER relay with the contact with the governor speed control circuit. We have previously established the flow of the control push button to the throttle down drum way within the P2 wire with the P2 wire with the in the finger with the throttle with the open with the notch with the AS finger with complete with the control excitation circuit. There was no increase with the engine speed, but the remains in the idle of 275 RPM. The throttle is open with the number 2 position placed slided under through the finger from the drum, goes through the finger and over the down through the ABER, which is now closed with the AV coil and the solenoid governor, causing the engine speed to increase to 350 RPM with the throttle and the number 3 position breaks the circuit with the AV coil, de-energizing the AV solenoid. Same type of the circuit, same type of the contact is made with the finger leading with the finger leading to the CV wire with the circuit travels way similar with the AV circuit that goes through the CD and ER to the CV solenoid, starting the engine speed to increase to 425 RPM. Throttle 4 position completes the AV and CV circuit, causing the speed to increase to 500 RPM. Throttle 5 number circuit, throttle 5 position established contact with the BV, DVV, and CV. The BV and CD and ER to the CV solenoid, DV circuit to the CD and IS to the DV solenoid. Thereby, the BVC and CV and DV solenoids energize the engine speed, increase to 575 RPM. Throttle 6 completes the circuit of the AB, VV, CV, DV solenoids, thereby increasing the speed to 650 RPMs. The throttle 8 uses the AB, BV, CV circuit to bring issues the engine to the maximum speed of 800 RPM, placing the throttle to the stop position using the DV circuit alone with the operator to stop the engine. The engine may be also stopped pressing the stop button, which also energizes the DV solenoid coming to the PC wire through the AB and IS, which is closed with the IS and starts the position, which is the stop button through the DV solenoid with the stop the engine. All right, 1 AC 1 and 2 and 3 and 4 stand for cooling fan motor contactors. AM of the battery changing ammeter, ammeter. The AV, BV, and CV and DV are the governor control switches. Governor control solenoids, which also go to the motor. The B1, B2, and B3 the dynamic braking contactors. The BA with the boiler arm alert. Light and the BC battery charging contactor, BF with the battery field contactor, BTP backward transition relay, BW dynamic braking warning light, BWR dynamic braking warning relay, CC control compressor magnetic valve, CCS compressor control switch, the COMM's communicating field, COMP compensation field, CR compressor control relay, CS the cam switch, the power braking the transfer switch, the DIFF differential field, ER for the relay, ETS engine high temperature switch, and FL field loop contactor, FOR reverse magnetic valve forward, FPC with the fuel pump contactor, FTM, the forward transition relay for the motor shunting, FTP with the forward transition relay, parallel G for the ground light, GA for the gauge light switch, GR for the ground relay, IM for the load indicating meter, IS for the isolation switch, LOS for the lubricating oil switch, alarm, M for the motor shunting magnetic valve, EM1, M2, M3, M4 for the motor field shunting contactors, the MOT cam switch magnetic valve with the form power position, N stands for number light, and NV stands for alternating failure signal light, NVR stands for no AC voltage relay, ORS stands for overriding solenoid in the governor, the OS stands for low oil signal light, P1, P2, P3, P4 stands for parallel contactors, PCR for the pneumatic control relay, PCS for the pneumatic control switch, PR for the parallel relay, RCR for the reverse current relay, REV for the reverse magnetic valve, reverse RVR for the reverser, and S14, S23 series parallel contactors, SH shield field contactors, SMV for the shield magnetic valve, the SR signal relay, ST plus, ST negative starting contactors, starting field, SWS summer winter switch, DCR for the temperature control relay, TOW cam switch magnetic valve with the dynamic braking, TS engine high temperature switch light, WSA wheel slip auxiliary light, WSR1 and WSR2 wheel slip relay, and WS wheel slip light. Your battery is a circle with two black pointed connections at it. Zigzag stands for a cool generator field in the motor with the field contactor relay of the contactor. A field zigzag in parentheses stands for reverse contactor service field. A throw switch with a heartbeat or heart line is a contactor with a blowout coil. The field bit looks like a drum type switch. A interlocking with a gated connection between a gate as a gate and line instead of a door swing. Storage battery, small and large spaced out dashes between positive and negative sign. Fuse is a swivel line with the amps above it. The ammeter with the stands is a block with a over it on the line. A rectifier is a triangle with a dash on it, non-filled arrowhead, non-solid arrowhead. The line with two dashes in it on a wire is a circle with a line and on a wire with two dashes in it is a light receptacle, two circles in it, a backup light receptacle, a circle in it with a battery charging receptacle, and just a circle is the light. The field generator, field contact motor, and relay generators, vertical standing, non-touching, stands for a transformer error card with the parallel lines format, a transformer air on core. Your single pole knife switch is a T door swing relay. A double pole knife switch is a two pole switches, two pole switches on one line and one switch. A single pole switch is a door opener with a doorknob, and a double pole switch is a double knife as a double open relay and a knob. And then you have your push button interlocking push button relays with a spring in it as a push button switch, or a pipe as a push pull switch. Your tooth and your box lines are fixed resistors, and when it loops back, it's a variable resistor. Your thermal relay and negative sign in a circle is a negative sided battery. Wire ground relay and arrowhead filled in with lines, and the arrowhead fill in shows the currents to continue to another plate. Parallel wires connected is made with a dot on the line at the two intersection. The seam of a 1Y and 2Ys is a capacitor. A toothed and single snap throw switch is a circuit breaker, and a rheostat is a field coil switched in a circle with a standing circuit to an gate flow. Alright, we're on engine speed, right? We're on engine speed. This should be an engine speed. Alright, that was engine speed. I guess I didn't put the relay in there, so moving on to 6th Circuit 7, three-way relay automatic transition. After reaching the full power of the locomotive speed, increasing to the point where the transition necessary to dilute the limitation main generator voltage, the transition must mean to be more speed with the desired. This is done by the charging of the circuit, which is the traction motor connected with the generator, with the comparable to the shifting of the gears in a car locomotive. The complex is the same. The changing of electrical circuits in operation raise of the main voltage is to be determined the valve of the initiating forward transition. Likewise, to increase the main generator with the current reduction of the voltage initiated in the backward transition. Transition from the serial parallel for the serial parallel shunt circuit is the valve of the main generator voltage is rises from the locomotive speed, and it will from the positive of the main generator through the fixed 10,000 ohms resistor variable with the 10,000 ohm resistor of the FTM with the coil back through the generator field to the negative side of the generator. The FTM interlocks, now closing the lower voltage circuit, the first of the excitation circuit, where just above the shield contactor coil will have the wire going for the right end of the down through the AB FTM into the M contact. This causes the M contactors to shunt the field line with the traction motor of the high voltage circuit, with the field FTM interlock with the CD FTM this closed with the control circuit just above the S14 coil, and perform the function of the establishing, holding the circuit, and use the next transition. The transition shades is completed with the locomotive picks up the speed. Transition from the serial parallel circuit of the parallels occurred with the next as the locomotive speed increases the main generator voltage continues with the rise in which the reach of the 950 volts with the flow with the available from the generator through the FTP coil with the back of the side of the generator, the FTP with the close with the contact with the low voltage excitation circuit. This below is then we have the circuit with the going through the right with the AP with the battery terminal positive, then down by the AB with the FTP with the EF, the MF, and to the PR coil with the PR interlocked with the function to make the transition to the following manner. With the first of all, directly above the PR coil, and the AB PR will close the establish holding the circuit with the PR energized with in the circuit leading to the SH coil with the EF of the PR opens with the brakes. The circuit with the SH opens with the SH contactor with the SH contactor opens the ABS. H will open the BF open coil circuit will open with the BF and contactor the CBNF, BNF is now close with the ORS circuit with the energizer. The ORS will quickly move to the lead with the regulator minimum of the field. The assessment of the DK with the main generator voltage. Main generator excitation recorded that the voltage now rapidly drop out of the FTM with the such with the 700 volts of the FTP within 630 volts. The AP of the FTM will open the dropping out of the M contact with the CD FTPM with located with the S14 control circuit together with the RQ with the PR will open the breaking of the circuit with the S14 which cause this contactor to open will now feed with the down with the correct control circuit with the CD with the PR which will close, and the AB with the 714 close with the P1 P14 P1 and P4 coils which will close in the P1 and P4 contact with the high voltage circuit, and the circuit leading to the S23 coil will now feed the AB1 and P1 will open, thus dropping the S23 contact with the high voltage in the circuit. Leading to the P2 on coils will find the AB and the S23 will now close the establishing the circuit with the close with the P2 to the 23 high voltage circuit. The transaction made motors are now connected with the parallel circuit across the main generator with the P1, P2, P3, P4 contactors remaining to establish the excitation circuit, but therefore with the circuit adjusted below the AB with the ground relay will come in straight down for the NPPR with the CD with the P3 with then left down with the S shield shield hunting contactor. This course is closed with the shield SH contactor with the turn and close with the BF contactor as described before. CD and BF will now open de-energize the ORS will determine the load generated with the function normally with the parallel transmission now allows the locomotive to increase the speed. Transition from the parallel to parallel shouldn't necessary to achieve the maximum locomotive speed accomplished with the main generator with the voltage again and rising 930 volts at the volt of the FTM with one to the pickup of the did not earlier transition serials parallel shunt. However, the parallel will need the excitation circuit through the AB FTM with the M with which closes the M contactors establishing parallel circuits with the last stage of the forward transition, the backward transition made with the locomotive slowdown with the main generated voltage drop looking in the main generator circuit of the FTP, and then it will note with the 10,000 ohm variable resistors now has been shunted with the closure of the GH and the PR with the AB with the M curve to the last forward with the transition lower with the dropout voltage of the FTM from the previous 700 to 600 volts with the main generator with the voltage drop with the value with the AB to the FTM will open the braking circuit with the dropout of the M contactor will have the backward transition and the parallel shunting to the contactor. The next backward transition parallel series parallel circuit is necessary with the braking of the circuit with the PR with the coil with the done with the AB battery positive transfer terminal positive. Since the BTP is located with the main generator circuit, directly will be noted with the field. Full generator current flows from the relay as if the locomotive slows down, the voltage drops and the amperage rises. The trickle the value of the relay with approximately 2400 volts with the down looking for 2400 amperes is now looking into the circuit with the PR with the coil noted with the AB with the BTP opens and breaks the circuit within the PR of the de-energized circuit with the change of the backward transition to the parallel C-wells parallel to the flowing with the manner with the BPR with the opens the dropping of the out of the SH the AB of the SH opens to the dropping of the BF of the CD of the BF closes to the energized the ORS which will minimize the load regulator toward minimum field assisting DK minimum generator field with the CD here opens the drop of the P1 P2 P1 P4 P2 and P3 AB1 and P2 and P1 and the RQ with the PR closing the picking up the closing of the shield series field 14 and 23 with the EF of the PR with the CD the 714 CD and 723 close with the pickup of the SH with the ABA of the SH now closes again with the pickup of the BF with the CD and BF opens to the energize the ORS allowed to load the regulator function normally. We now have the proceeding with the return of the original series parallel series. The various transition steps that have been completed backward, forward, backward, having allowed with the locomotive developing full power various speeds. This was the transition circuit. I guess I missed this one before the automatic relay. All right, we did the excitation circuit. All right, this one was the transition circuit. The battery is a 64-volt battery with the battery transferring the negative through this, which was go on to the. We'll go from the battery terminal negative at the slow switch, which goes to three different parallel circuits with the GN1, GN4, GN2, and GN3. On GN1 through GS1, you have two on the roundabout of GN1 from GS1. You have a three different compensation, communication, and differential field of the motor generator, to which looks like a small current which goes through the GCI one, which has a two different current line which goes in between the reverser contactor fields. It has a in this switch line it has a fixed resistor and a pole switch in between the fixed resistor, which goes to engine number one, and then from number one, it mixes in through. It goes 1, 4, 3, 1, 4, 2, and 3 motors, which have fixed resistors. And usually parallel one for 1, 2, 4 motors, fixed resistors, two different relays, and fixed resistors. Sorry. So you have your connection from GS, G4, GS2, GS3, all through fixed resistors and motors 1, 4, 2, and 3 of the excitation field, and they're on GN, G4, G2, and G3, and G3 through GN. You have two 10,000 fixed resistors, and there's three different lines from the G3 motor, but the two bottom lines there's a fixed resistor of 10,000 ohms, and then a variable resistor loop of 10,000 ohms, and a current from the FTP forward transition relay, and the forward transition relay and motor shunting. There's your positive polarity terminal negative in the transition circuit for the motors 1, 4, 2, and 3. On the battery positive side of the terminal, you see a 80 ampere. We'll go to the 80 ampere first. It goes into the serials and the parallel circuits of 1, 2, 3, and 4. The series 13 and the series. It has different interlockings of resistors, or should I say currents. It has AB interlockings on series 14 and 23, and then a series of on the ground relay side, it has different interlockings on the series of 14, and that goes back to the drum key of the transition control relay and the throttle control relay. And we're moving on. This is the last one. I didn't get a good shot of it, but it's the power transition cooling. These are the cooling fans. These are your transition traction motors. Lighting, battery charging, control, transition. I'm going to do a better job of this. Lighting, control, transmission, engine control, alarm signals. Thanks for watching.